Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! And you're probably wondering, what is this mess here? Well, mess is a good word for it. This is the power transformer out of my 300B amp. And it's been down for about a month and a half now. And I really miss listening to it. And lent it to a friend of mine when I was working on his R8, and he called me up and said, hey, it blew a fuse. I'm like, that's weird. Maybe I put a undersized fuse in it, and he was just listening to it louder than I normally do, so I didn't think too much about it. And when I took the R8 back to him, I picked up my 300B, brought it home, and pow, pops a fuse just as soon as you plug it in. It's like, what in the world's going on? So, started playing with it, put it on my DIN bulb tester, bright light. I'm like, okay, it's got a dead short somewhere. And started looking at stuff and measuring things and didn't really see anything obvious. So I disconnected all the leads from this transformer except for these two power wires that go to the 120 volts, and pow, still pops the fuse. So I'm like, I don't know what's going on. So I took the end covers off of it, and I don't see anything. Obviously, I didn't pull the tape off and stuff, but this transformer's been problematic since the first time I used it. I bought it originally for a Blue Glow KT88 style build, and I don't know if it was perfect for that either, because it's got kind of weird things going on with it. It's got two 6.3 volt windings that are good for 3 amps each. So it made wiring up the KT88 difficult because I couldn't put two KT88s on one winding. So I had to wire it up with one front end tube and one KT88 tube. It had two separate 6.3 volt windings running all through the thing. But anyway, I took that amp apart. I mean, I kind of liked it. We'll get into that in the Monday monologue about my feelings on KT88 tubes. But I repurposed this for a 300B amp. And I thought, this is perfect. It's got two 6.3 volt windings. We can use those for the heaters on the 300B tubes, since they need separate windings. And they don't need to be center tapped, which these weren't. And then I needed a center tapped winding for the front end tube. So I used a separate 6.3 volt transformer for that. Everything worked good except this thing had a bad hum in it. And you can see I put insulation on the inside of the end bells. Ended up having to mount it up on little rubber stands to get it tamed down enough where you couldn't hear it from my seating position, even though when you got about a foot from the amp you could hear it. And I was just never really happy with the performance of this transformer. So it dying, while it meant I had to do a pretty good bit of rewiring inside the power supply of the amp, I know I'm probably going to be able to get rid of the hum too. And we're going to replace it with a Hammond transformer. I'll put all these numbers in the description. Let's get into fixing my 300B amp. Okay, so the first thing we need to do is deal with mounting this new power transformer. And these are the little rubber insulators that I used with that noisy Edcor power transformer. And we need to install this slightly smaller Hammond one. And my hope is I'll be able to use the corners of the transformer to at least mostly cover up the holes in the amplifier. So I'm going to need to first remove these rubber insulators, because hopefully this one's going to be quiet and we can just bolt it solid down to the amp. And we've also got to install two of these 6.3 volt filament transformers on a direct heated triode. Each tube needs its own transformer, or at least its own winding. And the old Edcor transformer had two 6.3 volt windings in it that we used for the 300B tubes, and then we had one little transformer like this to do the heaters on the two front end tubes. And we're going to do the opposite this time around. We're going to use the winding in the power transformer to power these front tubes, and we're going to use a couple of these little Hammond filament transformers to power up the 300B tubes. We may have to put some step-down resistors in the front end tubes because I have a feeling that the 6.3 voltage is going to be a little high because it's rated at 6 amps, but we'll see what it is once we get that all connected. So first thing we need to do is take off these little rubber grommets, get this new transformer bolted down, and I'm going to just go ahead and probably drill these holes off camera and get this thing bolted down, and then we'll look at the wiring differences between this as I originally built it and then the way it's going to be wired up now. So let me jump on that. Okay, so first let's look at the schematics of these two different power supplies. This one here is the way I originally wired the amp. We're using this Edcor transformer that has sort of unique windings. It has two separate 6.3 volt windings in addition to the 5 volt and the 750 volt. And I had this left over from a previous project, and so I decided to wire this amp up with 5 volt regulated DC heaters because I knew that the 6.3 volt was too high just to directly power up the filaments, and it's just enough voltage once it's rectified to have these 5 volt regulators operate correctly. So if I was doing this over again, I might do things a little different if I was starting from scratch, or at least try something different. But given this amp's all built and I'm just wanting to replace this failed power transformer with a Hammond one, we're going to go with this schematic. And you can see in this schematic we have a single 6.3 volt heater winding with a 5 volt and a 750 volt at 200 milliamps, just like the previous one. So now we got to come up with an extra 6.3 volt winding because these directly heated tubes need their own transformer for each tube. So in this case, we're going to use the 6.3 volt one that is built into the transformer to power up the 6S and 7 front end tubes. And then we're going to install a couple of these 166L6 2 amp 6.3 volt transformers to take care of the 300B tubes. Now if you're building this amp from scratch, I would consider getting some 5 volt transformers and try running these with AC heaters. If you do that, you can directly hook the output of these transformers to the filaments and then use the hum pots to, find the quietest setting. Now it may have a tad bit of noise. I haven't personally done it. I know a lot of people run 300B tubes with AC heaters, and some people claim that they sound better. And it definitely would simplify the wiring. You wouldn't have to build these little regulator boards with the capacitors or the regulators and the heat sinks and all the extra complication that putting DC heaters in, although DC heaters do give guaranteed quiet operation of these directly heated triodes. So here we are looking at the inside of the amp. I'm going to show you some of the changes we had to make. You can see here we had to move the bolt hole over from here to here on each corner, and there's a little tiny bit of the hole showing on the top around the edge of the transformer. I'm not worried about it. It is what it is. It doesn't look bad. You'd really have to be looking for it to see it. So since I moved this bolt over, this tag strip with the regulator needs to be moved over a little bit so it doesn't short out. And you can see right here I drilled a hole over about 12 millimeters over. Going to bolt that down right there, and really not a big deal to move that over. So then the next thing I need to do is run the center tap for the main transformer's 6.3 volt over here to this voltage divider that lifts the offset on the center tap to 50 volts. And so we're going to run that kind of up under this cap and over here probably the first thing. Then we need to go ahead and bolt this transformer down. As you can see here too, I needed to grind off the shaft of this bolt where it came through the nut to get it as flush as I can, so this transformer that's slightly larger than the other one will clear. And it's going to sit in there like that, and then this wire is going to come over here to this tag strip to power up this rectifier for the DC heaters. So once I get this hooked up, I can get these wires and run them around the top of the transformer here down to our rectifier tube. And then I can also run these 5-volt heaters over here to the rectifier tube as well. Then we'll have our rectified high voltage DC coming out of our rectifier tube again to the rest of our power supply. So then the last thing that I need to do is come in here and I'm going to have to add, let me get these wires out of the way. I'm going to have to add another filament transformer, and there's just enough room right there to tag one in. And then I can run these wires over to the other rectifier that goes to the other 300B tube. So let me get all this wired up and drill some holes to mount this extra transformer, and I'll come back and show you what the final wiring looks like, and then we'll pull this thing up on the variac and check the voltage here on the 6.3 volts going to the front end tubes and make sure that it's not too high. It's probably going to be a little on the high side, and I'm not too concerned as long as it's not over 6.5, call the extreme probably 6.7 volts. If it's more than that, we're going to have to put a dropping resistor going to those front end tubes to make sure we don't overheat the filaments. So let me jump in and get that part of this done, and we'll go from there. Okay, so I got this all wired up, and this is a little messier than I would normally lay out an amplifier, but I'm having to kind of retrofit this stuff into an existing amp, and all this AC wiring is kind of piled on top of each other right through here, because the idea is to keep the AC wiring on this side of the amp and away from this side of the amp where the signal is. And so we have the 5-volt heater, we have the high voltage here, so we have the center tap hooked up to this star ground point. In this amp, all three of these are grounds. These are the two high voltage leads going to the rectifier tube. These are the 5 volts, and here's where the high voltage DC is pulled off and goes to the choke. This little mess here is where the heater for the front end of the tube is. It also has the voltage divider that lifts the center tap, and it's connected to this little strip here. And then this is our second filament transformer that we added. Let me zoom out here and kind of show you what all this looks like. So you can see we got kind of a whole bunch of stuff going on over in this side of the amp now. And this is because we had to add this second transformer in here, and a little bit of complication in the wiring. Like I said, if I was doing this from scratch, I would probably lay this out a little differently and kind of spread this stuff apart a little more. Possibly, move these capacitors over a little bit to give me some room in here to do some more work. I'm not sure, but I had to kind of squeeze it in here because I'm basically redoing the power supply of this amp to use this Hammond transformer. So the next step here is to bring this up on a variac, check our heater voltages, and make sure that they are in line, then pop the rectifier tube in and start checking our plate voltages and stuff and make sure this thing's ready to put into the system and see what it sounds like. Okay, so we're going to start with the variac turned about halfway up. So let's check our voltage here on the input. And we got 65 volts. Going to come over here and understand while I'm checking this, there's no rectifier tube, so there's no high voltage DC. The only place where there's high voltage is high voltage AC over the rectifier tube, and I'm not going to check that right now because I don't feel comfortable doing that with holding the probes like I am. So now we're going to check the low voltage for the heater supplies. It's the main thing we're concerned about right now. And you can see we got 3.5 volts, which is tracking to be in the right place. Then back here on the back of the amp, these are going to the 300B tubes. Remember, these are unloaded. I do have the tubes in the front sockets so that the heater for that part will be loaded so we can get an accurate voltage reading. And back here we got 4 volts. Then on this one we got 4 volts. And then let's come up here, carefully check the heater on the rectifier tube. Remember, this is unloaded. There's 2.7 volts. So now I say let's turn this thing up to line voltage. And we'll check, see if we have 120 volts going in. We'll turn it up just a breath. And there's our 120 volts in. Let's come over here and check the heater to the front end tubes. These are the ones I was worried about a little bit. And we got 6.5 volts. I'm not worried about that at all. I'm going to turn it up just a breath. Let me try to get this up to 121 because that's about what my line voltage is in my house. There we go. That's 121. And let's see where these heaters are at. We're at 6.6 volts. That's a little higher than I would like to see. I may come back in and play with putting a resistor in that heater wire, but for now, I know that's not going to fry it. Let's see what the unloaded voltage is on the rectifier tube, 5.2 volts. That should not be an issue at all. Then over here, the unloaded voltage on these other ones is 7.5 volts, which will come down once I put the 300B tubes in and put some load on them. 7.5 volts. And then we'll come over here and check the DC voltage on these filaments. And rectified, voltage regulated, 5 volts DC, even unloaded. We'll check the other one over here. And we got 5 volts. So we are fine. Like I said, I'm probably going to come back in and put a resistor in series here on this heater wiring going to the front end tubes to try to bring that back down closer to 6.3 volts. I was kind of worried given that this transformer has a 6 amp rating and we're only pulling a little over 1 amp, that the 6.3 voltage might be a little high. I don't think 6.6 volts will kill those tubes. It's within the 10% spec that they allow, but if I can get it down to 6.5 or 6.4 volts, I think I'd be happier with that. But I think this is close enough to put the tubes in it, do a final voltage check, and then go listen to this thing. Okay, first thing we're going to do is check the voltage going into the amp with the tubes drawing current and make sure that we're at or slightly above what our wall voltage is. And I'm seeing 121.6. 121 is about what my average is, so that should be a good indicator of what we're going to have in our normal operating conditions. Before I'd said I had the input tubes in place when I was checking the heater voltage. I didn't. And so now we're going to check them in actual operating conditions and see what this voltage is. And it's 6.52. I'm not concerned about that at all. 6.3 is optimal, and that's within a few percentage points of what perfection would be. I mean, 5% over would be 6.6. And so I can live with that without putting resistors in line with it. I know some people get real anal about that, but I'm not that concerned about it. Now, over here, let's see what the AC going into the rectifiers for the 300BR. We got 6.7. 6.7. That's perfect. Now we're going to do some low voltage DC testing on the heaters for the 300B tubes. 4.93. 4.93. Beautiful. That's exactly what you want to see on a heater on a 300B, right at 5 volts. If anything, maybe slightly under. And that should ensure a nice long life on those expensive tubes. So now at this point, we're going to start doing our high voltage testing. And I have one hand behind my back while I'm doing this. So we're going to check the voltage here coming out of these chokes that is filling up these big storage caps. And there's 422 and 420. That all looks good. Little bit lower voltage than we had out of the other transformer, which I think it had closer to 430 there, but not worried about that. We got 414 on that plate. Got 414 on that plate. Again, you know, that's a few percentage points lower than the plate voltage we had with the other transformer, but I'm not worried about that at all. That's maybe just, you know, a few percentage points of a watt less power. There's 65 basically. There's 64. Let's check this one again. There's 64 and a half. And there's 64 on the cathode of the 300Bs. That looks good. The plate of the first stage of the cascode, 91. 90. This is across the top of the cascode between the two tubes. 96. 98. And then the cathode of the bottom of the cascode, 2.27, 2.36. All those look like good numbers. I think we're ready to go plug this thing in and see what it sounds like. Like I said, there was a slight drop in the B plus from the other transformer, but I will happily give that up to get a silent power transformer for once. So let me go plug this thing in and see what it sounds like. Wait, who slipped in that fake demo video? You know I wouldn't approve of that. Anyway, what does this thing sound like? It sounds amazing, as it always did, minus the hum from the power transformer. Yeah, I don't have all blue transformers anymore. You know what? I'm not going to worry about it. Maybe one day I'll come back and paint the rest of these black. They're mismatched. I don't care. Like, what I care about is what this thing sounds like. The other thing that I think has improved the sound was I've been using NOS Sylvania tall bottle 6S and 7 tubes. And I bought some of these CV181-Z tubes when I bought my 300B tubes. When I looked at the data sheet, I got confused because the original CV181 tubes had a higher rated heater current. It was actually much higher than a 6S and 7. So you couldn't just plug them into an amp without ensuring that the transformer had the headroom for the heater voltage. Well, before I was using a small 1.2 amp heater transformer for the front end tubes, and that wasn't going to be enough for a pair of CV181 tubes. Now, I've seen conflicting information that said these new style ones or new production ones don't have those high current heaters. but when I put them in the amp and measured the voltage, it had more voltage drop than it did with the 6S and 7 tubes, which led me to believe that maybe these do have a high current draw. And so really didn't want to run them for any kind of period of time. I'm not even sure if they were working optimally. And so anyway, now I've got 6 amps of heater power in this power transformer going to the front end tubes that can easily drive these. And so was listening to them with these tubes, well, with the Sylvanias, then I put these in. These sound awesome. And they look great with these blacked out 300B-Z tubes, kind of matching with the porcelain base. And yeah, I'm sitting here talking about the transformers not matching, don't matter, but anyway, they look great, they sound good, and now I can use them because I got enough headroom in the transformer to run those. So I'm happy the way this turned out. I mean, I guess it was kind of a blessing that that crappy Edcor power transformer puked out on me, because I don't have to listen to it humming anymore. And I've really been using Hammond power transformers on every build since my problems with this one. And if you go on DIY Audio, there's a whole thread of people talking about noisy Edcor power transformers, and they don't seem to really want to do anything about it. They're kind of like, well, yeah, the power transformers make noise. Well, the Hammond ones don't. So anyway, I hope this video helps the folks maybe in Europe that need access to Hammond transformers. You can either use this 200 series or the 300 series. The 300 series, I think, is physically a little bigger and a little more expensive, but it's also got a shield in it. Who knows, maybe I should have just ponied up and bought a 300 series. The thing I like about the 200 series is it has a 125 volt and a 115 volt tap, so that if your voltages are a little on the high side or on the low side, you can use the other tap. And I found using these on the 125 volt tap, they run cooler and they're quieter. So that's why I went with the 200 series living here in the US. But obviously, if you live in another country, you're going to have to go with that. So anyway, I hope you enjoyed this little follow-up video. Maybe it'll help some of you folks that are interested in building this 300B amp see another way you could do it. Also kind of outlined you could use 5-volt transformers instead of using rectifiers and voltage regulators and all that to power the heaters on these. I'd love to hear from someone that's used, direct heated AC heaters on a 300B tube. If you've had problems with them, I think with these hum pots, they'll be fine. I'm using direct heaters on my 47 tubes. Not having any problem with that. I was planning to use it on direct AC heaters with my 2A3 amp as well. So anyway, if you're enjoying my content, please subscribe to the channel. Please like the video. And until next time, have a nice day.